We are going to start this lesson out by looking at Cavalieri's principle. So we have two stacks of index cards right here. And the question is, how are the volumes of the two stacks of index cards related? The first stack forms a right prism. The second stack forms an oblique prism. So a prism is a three-dimensional figure where the bases, so the base would be, let's say, this rectangle, and it has a congruent base on the bottom that is parallel to it. So that's what we call a prism. And if it's a right prism, if you were to connect the center of this base to the center of the base on the bottom, it would be perpendicular. So that's where the right comes from, forming a right angle. An oblique prism, if you were to connect the center of the base on top to the center of the base on the bottom, it wouldn't be perpendicular. So we will define this by saying that an oblique prism is a prism such that some or all of the lateral faces are non-rectangular. So this is another way to think about an oblique prism. So lateral faces are the faces that are not the two bases. So here I have a rectangular base on top. So this would be a lateral face. This one right here. If you can see, that is non-rectangular. It actually looks like a parallelogram. So that's what we will call an oblique prism. So the question we're being asked is, how are these two stacks of index cards related? Well, one thing we can take note of is here is the height of that stack of index cards. And over here, the height from the top to the bottom is the same measurement. So those two stacks have the same height. So we'll just make a note. Both stacks have the same height. So we are creating this stack by piling up individual index cards. So these index cards would represent a cross section of the prism. And so there's just a bunch of these cross sections piled on top, so a bunch of these index cards. The area of each index card, whether they're stacked straight up like this or kind of tilted like this, the index card did not change shape. So the area of each index card is the same. So if you are piling up a bunch of index cards that all have the same area, whether that pile is straight up or that pile is a little bit tilted, giving us an oblique prism, the volume of those two stacks will be the same because the sums of the areas of the cards are the same. And so that's kind of what we're getting to. We're getting to talk about volume. So this is the key information. The volume of the two stacks are the same, or the volumes. I'll say the volumes of both stacks are the same because the sums of the areas of the cards are the same. All right, let's read that sentence all at once. So the volumes of both stacks are the same because the sums of the areas of the cards are the same. So that leads us to Cavalieri's principle. So Cavalieri's principle states that if two three-dimensional figures have the same height and the same cross-sectional area, in the example above that was an index card, at every level, then they will have the same volume. So here we have, if we have three-dimensional figures where the cross sections have the same area and they have the same height, then the volumes will be the same. So now we can talk about the volumes of prisms and cylinders. The volume of a prism is the product of the area of the base and the height of the prism. So this is going to have a formula. Volume equals capital B times H. Now that capital B, anytime we use a capital B in our volume formula, that stands for the area of the base. And in this example, we can see the base is this bottom rectangle. It's not always what's on the bottom. You know, you could have a prism that's tilted on its side and maybe the bases are on the sides. But if you take the area of the base, so how, in this case it's a rectangle, so you take length times width, and then we multiply that by the height of the prism. The height is going to be what connects one base to the other base. So that's how you find the volume of a prism. Now cylinders are very similar to prisms because they have those two bases, only this time the bases will be circles. That's what makes it a cylinder instead of a prism. Well, a cylinder has the same area formula, same volume formula, area of the base times height. But we know if your base is a circle, then that area is pi r squared because every cylinder will have a circular base. So we can just replace that and say, well, that means that the volume of a cylinder is the area of the base, which is pi r squared times the height of the cylinder, h. But just let's make sure we're recognizing that prisms and cylinders have the same area formula. It's just every cylinder will have a circular base, so we know that this area of the base will always be a pi r squared. So sometimes we just shortcut to that.